Hello students, welcome to samclasses. Now today in this video, we'll be learning about the chapter sets and in the upcoming videos, relation and functions. So these three combined will be studying it, sets, relations and functions. The chapter is of very good weightage, good importance for the COMEDK. Now we didn't get the exact marks like the weightage, but approximate you can understand as sets contains around 3 to 4 questions. Okay, on an average 3 to 4 questions you can take it, sometimes very rare 5. We can't be very reliable because the book which we are following is not that reliable. Students understand, the book which is available right now in the market for COMEDK is only one book, and that is equal to, that is in Amazon, okay, in Flipkart also, by MTG, chapter wise and topic wise. Okay, but that is not reliable because the total marks of the math section, if you see, it's more than 60. So, but okay, still based on that. So we have this data. The chapter is very good. We have taken a parts of the video from the KCT concept also, the concepts which were similar, which were important, because a lot of KCT concepts are important and they're directly taking into COMEDK. The questions are directly pulled from KCT into COMEDK. Okay, so understand very properly, and we have less time to provide you with the crash. So we have taken a part of the video from the KCT and we have made a separate playlist. Okay, we didn't just say it, okay, you just go and study from the KCT this concept. Okay, we have taken whatever was needed from that part and we have merged and we have given somewhere a bit extra, somewhere not a bit extra, somewhere if it was enough we just kept it like that. Okay, change the thumbnail, made it into a separate playlist, and we are providing that to you. Okay, so if students some are of KCT, they'll find a lot similar with the concept, so you can go like with a 2x speed, just go through, zoom in. Okay, just go through, not zoom in, let's just go through and have an idea whatever the concepts are. For the students who are doing it for the first time, okay, understand each and every concept properly, make short notes, and once you have made the short notes, you can upload that short notes in our website, onlinesamclasses.in. We do grade your short notes, we do check your short notes, okay, and provide you a reliable feedback. Okay, so that's it. Start, work hard. We'll provide each and everything. By 10th, we'll be done with maths and physics. 11th is your first mock, 12th is your second mock, 3rd is your revision day, 14th, you hit for the exam. Best of luck. Let's start the chapter. So the chapter sets. Let's talk about basic of sets. What is it, and what everything. So first, set is nothing but a collection of well-defined data. What is it? Collection of well-defined data or objects. Now, a lot of students they'll ask, so what is this well-defined? Well-defined means something which we all, every human being can agree upon. Like let's take an example. Like you have taken an example like now, if I'm asking a question to someone who write the names of 5 best cricketers, so based on each and every person's perspective, the names will change. Somebody will say some other name, somebody will say Sachin, somebody will say Virat, somebody will say something Sehwag. Okay, so what will happen is the word best is different for different people. So this is not a well-defined data. Okay, so this all examples don't qualify for sets. Now we need to see something which we everybody and all people unanimously they can agree upon that yeah, this is the correct thing. This is we all agree upon, like the number of uh, the natural numbers between 2 to 10. So everybody, whoever it is, they'll agree upon between 2 to 10 is from 3 till 9. So all will agree, and this collection we'll call it as set. Now we have the sets of different things, and would say different numbers. So for natural numbers we denote it by n. For integers we have a set with z. We denote it. For rational numbers we denote it by q. For real numbers with capital R. For positive integers that is z plus. For positive rational number that is q plus. And for positive real number that is r plus. Now if somebody doesn't know what is natural number, integer and all that, you can ping it in the comment section. We'll tell you about that also. Now sets is expressed in 2 forms. Okay, we express sets in 2 forms. What are those 2 forms, students? The first is the roster or the tabular form. What is it? Roster or tabular? In roster or tabular, what we do, we write down the elements, okay, separated by comma. Like let's say 2, 4, and 6. These three elements are there which is belonging to a set, separated by comma and then the parenthesis. So elements separated by comma enclosed within braces. Okay. Now the other way of writing set is what? Set builder. Here, instead of writing the elements, we write the property by which we are forming the elements. So, like we have written set V, which is equal to X such that X is a vowel in English alphabet. Okay. So that is what, if the same thing we wanted to write in roster form, we would have written bracket and all the vowels which were in the English alphabet, A, E, I, O, U, correct? Now, a lot of people will say, sir, forgot the vowels, sir. Okay, it's pretty simple. Okay, now we'll be doing the English, English part, we can't explain it here. So, the math section will just explain it. So, sets can be represented in two forms. One is roster, the other is set builder. Roster, what do? You write down the elements only, separated by commas. And in set builder, you write the property by which you're forming or choosing the elements. Okay, that's it, simple. Okay, don't make it too complicated. Now, so we are teaching it from the exemplar book directly, okay, so that we are able to provide you in a fast manner and we are able to finish before the deadline notice. Now, whatever the things which will be left, which is not covered, we'll try to put a video on that also. So don't worry, we won't leave one thing also. Now, sets and the representation, we already got it. How to represent the sets, okay. Now, it is represented in two forms. One is roster, one is set builder. Okay, we already know what is roster, what is set builder. Now, next is different types of sets. Among the different types of sets, first is empty set. What is an empty set? A set containing no element. Okay, a set which does not contain any a set which does not contain any element. Okay, so that set is also known as void set or null set. What is it known as? Void set or null set. So we denote that set by just a bracket, empty or fine. Okay, clear everybody? Now, finite set. Just by listening to the word finite means we can count the number of sets. Finite means we can count the number of sets or the number of elements are finite. Infinite means we can't count. Now, can you think of an example? Yes, we can think of a lot of examples. Correct. What are those examples? Can you list up one? So do write out in the comment section what is finite set. One example of infinite set. Let's see who all is able to write and how much time. Very simple question. Okay. Now, next is what is a subset. Now let's say we have a set A which contains A, B and C, three elements. And we have a set B which contains B and C. Now when we define subset as if each and every element, if each and every element of any set is present in another set, then we say that that set is a subset. So you see, so if you see, we'll use a pen only. So if you see A is equal to, we have taken as A comma B comma C and B we have taken as B and C. So all the elements of set B is present in set A, yes or no? So you can see that B is a subset of A. So we write like this here, okay? Horizontal kind of view, correct? So B is called the subset of A, okay? So what is the definition of subset? If each and every element of B belongs to it, then B is called the subset of it. Again, let's recap it. What did we learn? We learned what is set, basic collection of well-defined, word well-defined was very important, well-defined objects. Next, we learned about the different notation for natural numbers. How do we donate it? For how do we denote it? For rational numbers, for integers, for positive, for negative rational numbers. Okay, we learned about this part, and then we learned what is the two different ways of writing sets. One was roster, one was the set builder form. Okay. After that, we learned about what is an empty set, having no elements, also called void or null set. Then we learned about what is a finite set. Finite means we can count. Simple. Okay. Infinite means it's huge in number, we can't count. Okay. Like And you can say all the natural numbers. It is infinite. Till how much it will go, we don't know. So the set containing all the natural numbers is infinite. The set containing natural numbers from 1 to 1000, it's finite, we can count it. Then we learned about what is a subset. Subset, what we define it as, if each and every element of any set is present in another set, then that set is said to be a subset of A. Clear? Done. No. So till here, any doubt, put it on the comment section. You can also join our WhatsApp group for any doubt, any kind of clarification. We'll be putting up the PDFs on the website and on the WhatsApp group also, and the DPPs. So do join it fast. Okay. Don't delay and start making your short notes. We'll be taking those short notes and we'll be putting it for review so that you are able to prepare in a dedicated manner. We are going a bit slow, but we are working damn hard to bring each and every content. Maybe it can be delayed, like we'll upload the video like 1 o'clock, 2 or 5 in the morning or 7 in the morning, but we'll put up every content. Okay. Before the due date of 15th, we'll put up every content. Next, we'll talk about equal sets. Now, two sets are equal if each and every element of A is equal to each and every element of B. Here, order doesn't matter. Let's say A is equal to, we have 1, 2, 5, 7, and B is equal to 7, 2, 5, 1. Now, see, each and every element of A is present in each and every element of B. Correct. Every element of B is present in every element. Or what is it? In A, correct? So we can say A is equal to B. The order, student, doesn't matter. Okay? Keep in mind, order doesn't matter. Now, in order to represent what is a subsets in the intervals forms, what we do on a number line, I think so you have learned in class 11th linear inequalities, correct? In the chapter we learned how do we express numbers on the number line like a continuous numbers, okay? Like starting something is greater than 2. Let's say if we have a number x which is greater than 2 but less than 5. So how do we represent on a number line? So what we do on a number line, let's say this is 0, this is here 2, this is here 5. So we start from 2 and we go till 5. Now we keep this open here and here. Why? Because it is not containing this 2 and not containing the 5. So that's why we denote that, or we write it out by open bracket 2, 5. It means that everything between 2 to 5 except 2 and 5. Okay. The end values we are not taking, student. Okay. Understand it, very important. So the moment we have an open interval a comma b, it means that every value between a and b, but not taking x equal to a and not taking x equal to b. Okay. Now, moment we have close bracket or square bracket like this, then we say we are taking every value between a and b, including the extreme value x equal to a and x equal to b. How do we write it on the number line? I'll again show it. Let's see. Let's say we have to show we have a number 0 and x is from greater than equal to -3 and less than equal to 10. So this is -3 and this is 10. So the moment we have equal to, it means we are taking the end points -3 and we are taking the end point 10. So all the values from -3 to 10 we are taking it, student. Okay, clear? And that's why we put a square bracket. This square bracket or close bracket 3 means we are taking this value 3 also. Okay, it is starting from this value 3 and going till this value 10. Okay, clear? So very important, small things. Sometimes we skip in the answer, we overlook it. Let's say an answer is given 10, 6 open bracket, and one answer is given 10, 6 close bracket, and in actual answer while solving you got it is greater than equal to, let's make it 16, greater than equal to 10 and less than equal to 16. So which answer will be correct? Somebody was in very fast hurried mode and he put this answer and he was like very damn happy. I'm given a damn good test, sir. I'll get out of out. But he has overlooked the fact that here 6 is what? Open bracket. 16 is what? Open bracket. So this is not open bracket he got. He got less than equal to 16, means it will be a closed bracket. So small things matter a lot, students. Do work on that. Okay. Now, So A comma B close bracket means that X is, or one bracket is closed, one is open. It means X, the moment which is closed, it is greater than equal to. So X is greater than equal to A, but less than B. Now here A has open bracket and B has closed. So it means that X is just greater than A. It is not taking A, but it is less than equal to B. Okay. So everybody got this concept? Anywhere, any doubt, student? Put on that timing, write it down on the comment section. We'll definitely address it in the doubt session. Okay, so don't worry about that. Now, next concept is power set. What is this power set? Okay, so let's understand what is this power set. It is nothing but the collection of all the subsets. What is power set, students? Collection of all the subsets. So if I have a subset, let's say if I have a set A, and that is equal to 1 comma 2. How many subsets will it make? So let's see. First, always remember phi is a subset of every set. Phi is means null set or empty set or void set is a subset of every set. And then we have set containing 1, set containing 2, and one the last one will be equal set 1 comma 2. So total we have how many? 4. So from this we can come up to a formula. If the number of elements in the set is 2, the total number of subsets is 4. So it means that 2 power n, where n is the number of elements of set A. Correct. So this formula is also very important, and a lot of times it's asked. So if the number of elements of A is n, okay, then the number of total power sets is 2 power n. Okay. So let's see a very small question. Do it fast. Okay. Pause the video. Don't what do you say? Listen to the answer. If they have given that A contains total 1 comma 2 comma 3 comma 4 elements, what will be the total number of power sets? Do pause the video. Write down your answer in the comment section. And now you check. Just now we told the number of elements in A is equal to what? 4. So the power set of A will be what? 2 power 4. So that is equal to what? 16. Clear? Whoever got 16, very well and good. Very simple question, very simple answer. Okay. Now the next part is, by the name you can understand universal set. What is a universal set? The word tells universe means what? Everything. So a set, it's an imaginary kind of concept. A set which contains everything is known as a universal set. Okay. Now it depends on what you say. Each set with what we can make universal. Let's say we have taken a set A which contains two elements 1 comma 2, and I have taken a set B which contains 1 comma 2 comma 3. So this set B can act as a universal set for it, because whatever elements that A can contain, B contains, and it has more than that. Okay. So universal set is kind of like what do you say, a set which is containing each and every element of that. Okay. So universal set is pretty simple. Now for a set of, like, we can make it big. If I have 1 comma 2, best will be to form a universal set will be, we can take universal set equal to set of all natural numbers. Set of all natural numbers. So if somebody says, sir, if you have taken natural numbers, sir, why not take a whole number? Yes, definitely we can start with a whole number. Now somebody will say, sir, whole number you're already taking now. Come on, take some more. What do you say? All the integers also. So we'll include, let's say the universal set contains all the integers. Somebody says, sir, we can go in a much broader sense. If we can go for the integers, we can go for the rational numbers also, including the fractions. We can go with the rational numbers also. Then again, the point will come. What if we are going with the rational, why not all the real numbers? We can go with that. So the concept is a set which can enwrap this whole set, okay, can become a universal set for that. Okay. Now, Venn diagram is nothing but a pictographical representation or a graphical representation, diagrammatic representation of the set part. Okay. So we represent the universal set with a big rectangular box and the other sets with a small circles. Okay. Clear? So let's see. Now let's add a page here. Okay. So here, students, let's talk about, let's say this is my universal set U. Okay. And I want to write a set A. So I brought, so A is, this is universal set. and A is within that set, correct? Now I wanted to show a subset B, which is a subset of A. B is what? Subset of A. So by the definition of the subset, what we know? That it should contain each and every element of B should be present in A. So by the definition, what will be? B will be inside A, correct? Each and every element of B is present in A, correct? We can understand now. Simple it is, okay? Now we'll define few things. We'll learn about union of sets. What do you mean by union? Union basically means addition. Okay. So basically union means, let's say if I'm doing union of two things, it means it will contain the things of A and the things of B. So when we do this is A, this is B, union means it will contain both of them. Okay. So now if they have something in common, so it will contain one type, because just now I told you in the starting part, we don't repeat in the sets. If a set has, like, let's say A has 1 comma 2 comma 3 comma 4 comma 4 comma 5. So like set A has, we don't repeat the elements 1, 2, 3, 4 and 5. Okay. Now, let's see what does the union stand for. So, union stands for all the elements of, what do you say, a set which contains the first set also and second set also. Let's see. So, we have set A like this here and set B here. They have something in common. We'll discuss about the common. So, whenever we say A union B, it means we want each and everything of A. Along with that, we want each and everything of B. Okay. So, A union means the what? That X either belongs to A or X belongs to B. Clear? Now, what are the different properties if I'm doing A union B and B union A? Is it the same thing? Correct? A union B means everything from A and everything from B. B union A means everything from B and everything from A. So there is no difference in this. Now, if I do a union with 5, 5 doesn't have anything. So I'll get the same thing, same set. If I do a union with universal set, a universal set contains everything. The moment I do union, this will dominate, the bigger will dominate, simple as it is. Now we can do this also, A union B, union C, means I'm doing first union with B, and then together I'm doing union with C. That is same thing as doing B union C first and then doing B union with A. So ultimately what does it say? That it should be a set which should contain A, every element of A, every element of B, and every element of C. Whichever order you take, it doesn't matter. Now, if I'm doing A union A, so it will give A only, correct? Because everything present in A, both as A only. Now, what is intersection? By the word intersection, we understand common, which is meeting point. Okay. So, A intersection B means what? It should present in A and it should be present in B together. Okay. So, we can see in the Venn diagram form, A intersection B is nothing but some things which are present in both A and which is present in both B. So that is, this part is nothing but A intersection B, student. Okay. It is written by, what do you call it as? Downward U. Correct. And union is upward U. Okay. A union B. This is union. And this is intersection. Okay. A intersection B. Okay. Any doubt, you can put, you have 3 options. Put it on the comment section. You can comment in the, what's the WhatsApp group also. You can join and you can get the PDFs and the DPPs and you can comment there. And you can log into the website and you can, put your doubts there also. Coming to the next part, if we have nothing in common, so they won't intersect, correct? They don't have anything in common. So these kinds of sets are called disjoint. What is it? Disjoint means no joint. Okay. The word only says like what, we don't have to mug up anything. Okay. Disjoint, no joint, student. So they don't have anything in common. A intersection B is what? Illa, nothing. A intersection B is what? 5. Okay. 5 means nothing. Okay. Clear? Now. Same thing, few properties are there, that A intersection B and B intersection C, A is same thing. We all know. Okay, if I do an intersection with nothing, I'll get nothing only because nothing is there. If I do an intersection with all the things, I'll get the same thing, A, the smaller ones. Okay, so that is there. Next important concept is difference of set. So very simple difference is there. Let's say I have this A, this B. So the moment I say A minus B, the moment I say A minus B, what does it mean, student? It means that take from A, remove the things of B. What does it mean? From A, remove the elements of B. Remove the elements of B. So let's say this is A, this is B. So basically, the moment we say A minus B means from A remove all the elements of B. So just the common part we have removed. So that is A minus B. Now if somebody says, sir, you defined A minus B. What about B minus A, sir? Same thing. From B remove all the parts of A. Correct. Nothing more than that is there. Correct. So difference of sets means what, student? A minus B, when we say A minus B, what does it mean? One second. When we say A minus B, what does it mean? From A, remove the part of B. From A, remove the part of B. Okay. So, like in reality, also we use this kind of thing. You remove this friendship from me, means from whatever my life is happening, I want this part of the friendship or this person's friendship to go out from my life. Correct. So we say, I want to cut it out. I want to, what is it, subtract this friendship from my part, my life. So that means that from my life, whatever the part which was intersecting with the other person, which I want to remove, that you have to remove it. Correct. So A minus B means what? From A, you remove the part of B. Okay. Next is complement of A. Next is complement of A. Complement means from the universal set you subtract it. Complement means from the universal set you subtract it. Means let's say A is this set, okay, and this is my universal set, okay. So whenever I ask for A bar, okay, complement is denoted by this bar or dash. It means that from the total universal set you subtract A, whatever you are getting, that is complement. So if I say A is nothing but what is it? Natural even numbers. Natural even number. So universal set is, let's say, natural numbers. So what will be A bar? Natural odd numbers. Correct. From the total numbers we are removing the even. So what will we get? Natural odd numbers. Clear? Now, a few laws are there which are very important. Let's see. If I'm doing a intersection with A intersection A bar, so I'll get 5 because there is nothing common. If I do common with 1 part and 2, there's nothing common. Correct? Now this De Morgan's law, very important, student, okay, we'll be using it a lot. Okay, so be careful. A union B whole bar, if you all have studied computers, so then you will be knowing it, okay, and A union B, if I'm doing whole bar, okay, complement is nothing but A complement, change this sign, union will be changed to intersection, intersection will be changed to union. A bar, intersection B bar. So if same thing, if you have intersection here, student, what will happen? So it will be A bar, union B bar. Clear? That's it. So what is the, if I do double complement, okay, so A bar and I'm doing one more. So I'll get the same thing here only. If I'm doing universal set complement, I'll get 5. If I'm doing 5's complement, I'll get universal set. Now formula for the intersection of two sets. Very simple. We'll just derive it, we'll show it. Okay, let's see. So here in the Venn diagram, let's say this is my set A, this is my set B. So this is, say, let's say one element A, element B, element C. So when I say n of A union B, so basically means what? We mean every element of which is lying in A and lying in B. So that is equal to what? A comma B comma C. How can we write it? We can write it as n of A plus n of B. Now whenever I am writing n of A, what are the elements n of A contains? A comma B. And when I'm writing n of B, what does it contain? B comma C. So if I see two B's are coming, so I'll subtract one extra. N of A intersection B. So one extra B will subtract from here. So we'll get A comma B comma C. So what is the first formula we have? N of A union B is nothing but N of A plus N of B minus N of A intersection C. Now for the 3 1 also we have a formula for 3 sets, okay, like A, B, C, like this. So N of A union B union C is nothing but N of A plus N of B plus N of C minus of N of A intersection B, N of A intersection C minus N of B intersection C plus N of A intersection B intersection C. Okay. Now, formulas, we're not going on the derivation part because, again, we are not studying for the PU or 12th. So, we're going for the KCT crash. We'll see how to solve the questions. These are the basic formulas. Whatever extra, we'll put up again a bit, okay, with the questions only, with the PYQ, we'll take care of that. Thank you, students.